word. Should be good to go. Okay. All right. So 6.3 is all about complex fractions. Okay. In my high school classes, I joke around. I say fractions are the math cuss word. I call it the F word. So when I say fractions, everybody oohs. Okay. These are complex fractions, fractions within fractions. So I call these mother fractions. Okay. So this would look something like, okay, Layla, were you able to get on? Oh, she was there and then she was gone. Okay, mother fractions. Anyway, we've got a fraction over another fraction. Okay, so this is saying 1/2 over 3/4. Okay, and usually it's pretty easy to tell that it's a fraction, so it's not like a gigantic thing, but anyway, it's usually like this. So you got 1/2 over 3/4. Okay, and there's two ways to look at this problem. When it is simple and straightforward and you have two regular fractions, it's actually easier to look at this as a division problem than as a fraction problem per se. So if we look at this as division, then what we have here is 1/2 divided by 3/4, which is more what people are accustomed to seeing whenever it comes to fractions. Okay. And as a reminder, we did this last time. Okay. When we covered division, we actually don't divide. We change that division to multiplication, and then we multiply by the reciprocal. So we'll actually flip that second fraction. And then we multiply straight across. 1 times 4 is 4. 2 times 3 is 6. Reduce that to 2/3. Okay. That is one way to look at a complex fraction. So again, a complex fraction is just a fraction over another fraction. And one way to look at that is that it's a division problem. And again, if you're dealing with simple fractions, that's probably the easier way to go about it. Okay, not the only way. And this will actually make more sense once we start throwing in X's and Y's and all kinds of nonsense, and the instructions are going to tell you to simplify this. So in the process of simplifying a complex fraction, you can do division, which is multiplying by the reciprocal, or you can do what I'm going to show you here. Okay, to simplify a complex fraction, you can multiply everything by your lowest common denominator. So if we look at these denominators, denominator just means the bottom number of a fraction. Okay, so if we're looking at 2 and 4, the lowest common denominator, what these both go into is 4. So I can multiply the top and the bottom by that lowest common denominator. Okay, what happens when we do this? Okay, 4, if we multiply a number times a fraction, this is like saying 4 over 1. So we multiply to the top and then divide. So 4 times 1/2 is 4 times 1 divided by 2, which is 2. Another way to say it is just half of 4 is 2. Okay, but again, the actual mechanics, you multiply to the top and then divide the bottom. Same, 4 times 3/4. 4 times 3 is 12. 12 divided by 4 is 3. And if you'll look, that yields the exact same answer. So it's really two different ways to kind of look at how to simplify a rational expression, okay, or a complex fraction. Again, you can look at this as a division problem where we multiply by the reciprocal, or we can simplify by multiplying by our lowest common denominator. So again, if we look at the denominators here, we figure out what do they both go into, and then we can multiply by those. That clears everything out. And as long as you pick the lowest common denominator, that actually kind of simplifies for us as well.
I started in bodybuilding in 2000.
Okay, so they're rarely going to give you something with just numbers. They jump right in and they're going to start throwing some wackadoodle stuff at you. For example, if they gave us a problem like so. Okay, we have 10 over 9x over 5 over 9x. So again, we've got a complex fraction. We've got a fraction over a fraction. And again, we can look at this as division or multiplying by the reciprocal. I want you to get used to doing it the other way, just because once we start doing some of those more complex things, more complex expressions, it's really, really easier to do it that way. So if we look at our denominators, those 9x's, when you have the same denominator, finding the common denominator is really easy. We're going to take the top times 9x, and we're going to take the bottom times 9x. Because our denominators are the same, that is our lowest common denominator, LCD. Okay, again, when you multiply, you take this number times the top, and then you divide. So 9x times 10 is 90x. 90x divided by 9x is just 10. In fact, if you want, you can divide first, which those actually cancel each other out. 9 divided by 9 is 1. X divided by x is 1. 1 times 10 is 10. Same thing. You can multiply to the top, or if you want, you can divide first. So 9x divided by 9x is 1. 1 times 5 is 5. So this reduces to 10/5, which in turn reduces to 2 over 1, or 2. Now, when you have a number over 1, you can leave it over 1. I think I would actually prefer you to just write it as a regular whole number, but technically both are right. I know my math lab would rather the whole number answer. Okay, then they start throwing more stuff at us. They start throwing some addition expressions or subtraction expressions in here. So now we have x plus 7 over 2 over x minus 1 over 8. Okay, again, look at your denominators. We have 8 and 2. So we want to find that lowest common denominator. So what do 2 and 8 both go into? So not what goes into them, but what do they both go into? So 8 times 1 is 8, 2 times 4 is 8, 2 and 8 both go into 8. So that is our lowest common denominator. So again, we're going to multiply. Now, when you have a binomial like this and we multiply, we got to distribute. So we got to do 8 times x, which is 8x. We got to do 8 times 7, which is 56. K over 2. Same game, distribute here. 8 times x is 8x. 8 times -1 is -8. And that's all over 8. And when you divide here, you've got to divide this into both of those. So 8x divided by 2 is 4x. And then 56 divided by 2 is 28. 8x divided by 8 is 1x. -8 divided by 8 is -1. And this is actually my simplified answer. Some people run into trouble because they try to get cute and they're like, oh, look, I see these x's and I can just cancel those out. Okay, that's not how math works. You can't just break up an addition problem like that. When we reduce, for example, this 10/5 did reduce to 2 over 1. Okay, but remember, I talked about this last time. That's because 10/5 can technically be rewritten as, okay, 10 is 5 times 2. and 5 is 5 times 1. So if you're multiplying, okay, sorry, I'm out of focus. There we go. Okay. When multiplying, you can have a common factor and we can cancel those out. And that's where we get our 2/1. Okay. But not if it's addition. Okay. So if I rewrite this as say 5 plus 2 over 5 plus 1. Okay. I can't just cancel those 5s and this be 2 because if we add, that would be 7/6, right? So when it's an addition problem, you can't just cancel your x's like that. You can only do that within a multiplication problem, if that makes sense. So anyway, when you have a problem like this, 4x plus 28 over x minus 1, you can only cross out or simplify if you have a common factor, meaning multiplication. Okay, so this is technically simplified. All right, the next 2 or 3 problems I'm going to show you is what I consider to be the ugliest problems of this particular section. Okay, plain old whole numbers, not too difficult. Okay, if they just throw in an x here, but you still just got kind of a simple expression, not too difficult. Simple expressions, okay. But this is kind of where the rubber meets the road, and they'll throw at you something like this. All right, so say we've got 5 over x plus 6 over 25 over x squared minus 36. All right, so this starts the ugly stuff. The steps, the process is going to be the same. I just kind of want to show you what this is going to look like. Okay, so we still have a complex fractions. We've got fractions over fractions. Again, I call those mother fractions. Okay, to get rid of that, we're going to do the same steps. So we're still going to multiply by that lowest common denominator. So if we look at our denominators, just focus on the bottoms here. We have x, and we have x to the second power, or x squared. Okay, again, looking at what they go into, x can go into x squared, not the other way around. X times x is x squared. So anyway, we can multiply by an x squared. And again, when we do that, we got to distribute. So if I take x squared times 5, that's 5x squared, okay, over x. And if I multiply x squared times 6, I get 6x squared. Sorry, it keeps going out of focus because my hand goes in front. Should catch back up. Okay. Same thing. If we multiply x squared times 25 over x squared, we get 25x squared over x squared. Minus 36x squared. Okay, when we do this, then we do our division. So 5x squared divided by x. Okay, remember, subtract your exponents. 2 minus 1 is 1. So this is actually 5x plus 6x squared, because again, basically one of those x's cancels, over, okay, x squared over x squared, because it's multiplication, those two do cancel each other out, and we get 25 minus 36x squared. All right. We can't, now it does look like we should be able to do something with this because it just looks like there's too much going on here that looks similar or looks like the same. Okay, we can't just straight up cancel pieces because again, we're adding and subtracting. But what we can do, what we learned last chapter, okay, to simplify, we can break this up into its factors. So if I factor these things, okay, if I look at 5x and if I look at 6x squared, these both have an x in common that I can factor out. Okay, this has a greatest common factor of an x. If I divide an x out, then I get x times 5 plus 6x. Remember, factoring is basically undistribution. Okay, and 25 minus 36x squared. 25 is a perfect square, 36 is a perfect square, and we're subtracting. So this one factors into 5 plus 6x and 5 minus 6x. And now that we're multiplying, okay, this is multiplication, you can start canceling out your common factors. So this 5 plus 6x on top and this 5 plus 6x on the bottom cancel each other out. And your final simplified answer is x over 5 minus 6x. Okay, I'm going to do two more examples, a lot like this one. They're going to look a little bit different, but kind of the same. And you're going to see the steps are going to be the same. So we always multiply by our lowest common denominator, see if we can factor anything, and then see if we have any common factors. 3 steps. Okay, so again, probably the most simple type of problem you'll look at, slightly more difficult, probably the hardest kind of problem you're going to have to deal with for this section. Okay, I'm going to do another one kind of like this bottom one here. Let's do that. All right. This is all kinds of ridiculous. So we've got x minus 3 over x squared minus 16 over 1 plus 1 over x minus 4. Gross. All right. One thing that's going to help is if you remember last section, okay, not last chapter, but last section. So last Thursday, okay, when we were adding fractions and trying to find a common denominator, okay, it helps to factor. All right. So if you're looking at your bottoms, okay, if something factors, we need to simplify that. So I'm going to rewrite this with a factored bottom. Okay, what that means is, so x squared and 16 are perfect squares. So just like we did with the 25x and 36x squared, x squared minus 16 is actually x plus 4 times x minus 4. This is a difference of perfect squares. So now it should become a little easier to see what your common denominator is. So this one has a denominator of an x plus 4 and an x minus 4. This one has a denominator of just an x minus 4. So your common denominator is actually going to be both of these. Okay. So we're going to multiply x plus 4 and x minus 4. Same thing here. We're going to multiply x plus 4 and x minus 4. You don't have to write them like a fraction. I just didn't have a whole lot of room. Okay, we're multiplying both of those quantities. And if we multiply, remember you multiply to the top and then divide. So actually these things cancel each other out, leaving me with just my x minus 3. Okay. When I multiply to 1 here, nothing cancels out. So we get both of these, x plus 4 times x minus 4. So that's when I multiply by the 1. And then when I multiply here, my x minus 4s cancel. And that leaves me with just x plus 4. All right. So again, to reiterate, the x squared minus 16, I broke it up. I factored it. And that helped me find my common denominator, which was x minus 4 and x plus 4. When I multiply, both of them cancel, leaving me with just x minus 3. When I multiply to 1, nothing cancels. I get both of them. When I multiplied here, my x minus 4s cancel, leaving me with 1 times x plus 4. Okay, so all I got to do is see if I can clean this up. If we multiply the bottom here, okay, we get x squared minus 4x plus 4x minus 16. So that's x squared minus 16 plus x plus 4. So if we combine like terms, so that's x squared plus x minus 12. So this might be my final answer. The only thing I got to look at is, do either of these factor? Okay, can I break this down anymore? Well, x minus 3 doesn't factor, but x squared plus x minus 12 might. So if I look at this, x squared is x times x. And I'm looking for two numbers that multiply to get negative 12 that add to get 1. Okay, that'd be positive 4 and negative 3. So technically x squared plus x minus 12 factors into this, and I have common factors. So when it's all said and done, I end up with 1 over x plus 4. That is by far the ugliest problem in a section like this, because we got a factor to even get started. Okay, then we've got to refoil, and we got to factor again and look for common factors. All right, I'm going to do one more of these, and then we'll move on to 6.5. All right, last one. So we got 25. Sorry, I keep bumping my camera. 25 x squared minus y squared over xy over 5 over y minus 1 over x. All right, again, step one, to get rid of this, to simplify it down, we need to multiply by our common denominator. So if we're looking at our denominators, we got an xy, we got a y, and we got an x. So to make sure we have all of these accounted for, we're going to multiply by an x and a y. Okay, because this one has an x and a y, this one's just a y, this one's just an x. That's my lowest common denominator. So whenever I multiply, these xy's actually cancel. That leaves me with 25 x squared minus y squared. Okay, when I multiply to this one, the y's cancel. So that leaves me with 5x. When I multiply to this one, the x's cancel. That leaves me with 1y. And to see if this simplifies, I got to see if anything factors. The bottom actually does not factor, but the top does. Those are perfect squares. This factors into 5x plus y and 5x minus y. And again, once we make this a multiplication problem, if you have common factors, those will cancel. And we end up with 5x plus y. All right, that's basically complex fractions, and I'm going to talk about this a little bit more whenever it comes time for the test. But whenever we test, there's probably going to be 3 questions. I would anticipate one of about this level of difficulty. I would anticipate one of about this level of difficulty. And I would anticipate one of about this level of difficulty. So there's going to be one fairly straightforward, one with a more simplified expression, and then one of the more complicated ones where we got to do some factoring and whatnot. So anyway, that's a pretty good indicator of what I would expect you to be able to do to perform on the test. And like I said, I'll cover that a little bit more whenever we actually get done with 6.5, but that is 6.3. All right, moving on, 6.5 is solving rational equations. So this is the one section where we actually do some solving, and we're going to end up with pretty little answers. Okay, everything else from before was some sort of simplification. We were checking on the domain, or maybe we were simplifying, or we were adding or multiplying, or doing that whole complex crap we just did. Okay, this one is all about solving. We're trying to figure out what x is, or y, or a, or b, or whatever. Okay. And actually, this is all going to stem from stuff we talked about in the very first chapter. Okay, so the very first chapter, okay, we had to solve some equation involving fractions. Okay, we learned a shortcut that tended to help us with this, and we could clear our fractions by, again, same idea as last time, if we multiply everything by that lowest common denominator. And as long as we multiply everything by that lowest common denominator, that kind of cleared out our fractions. So we're going to take this same concept okay, we multiply by the common denominator, multiply and divide. So 15 times x divided by 1 is 15x. 15 times 2 divided by 3. 15 times 4 divided by 5. And then we can turn around and solve this. Subtract 10 from both sides. Divide x equals 2/15. Okay, that is the most basic type of solving equations involving fractions. Okay, in fact, we've already done a handful of these. Okay, but that's the same idea. So it's going to be multiplied by the lowest common denominator, get some simplified equation, which we can then solve for x. So we're going to do more of the same. So they're going to give us something like all right. So they're going to give us something that looks like this. So we've got 1 over 5x minus 1 over x plus 2 equals 1 over 3x squared plus 6. X. Sorry, I should have an x here. All right, so same concept. If we want to solve this, if we want to do what we can, we got to get rid of our fraction. So we need to multiply by our lowest common denominator. So we're going to take that same concept. We're going to multiply everything by our lowest common denominator. The trick is the lowest common denominator is not obvious. All right, we've got a 5x, we've got an x plus 2, and we've got a 3x squared plus 6x. Just like before, and like last time, to find the common denominator, it's usually helpful to factor if possible. For example, if I'm looking at this 3x squared plus 6x, okay, there's a greatest common factor here. I can actually factor out a 3x, and then that leaves me with x plus 2. So if I factor that 3x squared plus 6x, basically this is just another way to rewrite that, which makes my lowest common denominator a little more obvious. I didn't leave myself enough room over here, so I'm going to write it over here. It's going to work out the same. Okay, so I'm going to multiply by that lowest common denominator. So looking at my denominators, I got an x plus 2, so that's going to be 1. I got a 3 and a 5, so I need both of those. And I got an x, so I'm going to need one of those. So my lowest common denominator is basically all of those pieces. So the x plus 2, got it. 5, got it. 3, got it. Okay, and then x's, got it. Okay, so whenever I multiply, some of this stuff is going to cancel. It's going to kind of look backwards because I ran out of room, but it's all the same thing. So if I multiply here, okay, the 5 and the x are going to cancel, leaving me with a 3 and an x plus 2. Okay, when I multiply here, my x plus 2s are going to cancel. And that leaves me with a 3 and a 5 and an x. When I multiply here, the x plus 2, the 3s, and the x's all cancel, leaving me with just the 5. But once I've done that step, I don't have fractions anymore. This is just a regular linear equation that I can solve. So if I follow my math here and just distribute, so I get 3x plus 6. 3 times 5 times x is 15x. Combine my like terms, 3x minus 15x is negative 12x. Subtract 6 from both sides. Divide, x is 1/12. So there's the whole problem worked out. Now, we don't have to worry about it so much with this problem, but whenever you're dealing with fractions, you need to double check. Your answer may cause division by 0. Once you start putting x's in the bottom of your fraction, you got to double check and make sure you don't have anything that causes division by 0. We talked about that, okay? Division by 0 is bad. You cannot divide by 0. It is an undefined value. So if your answer causes division by 0, it's not really an answer, okay? Now, in this case, we don't have to worry about it. 5 times 1/12 is not going to be 0. 1/12 plus 2 is not going to be 0. Same thing, 3 times 1/12 or 1/12 plus 2, none of that's going to give me 0. So this particular solution is fine. It checks out. I promise you there are going to be some problems, and I'm going to show you them in the next example. okay, where if you look, one or more of your answers are going to cause division by 0, and you can't have that as an answer, okay? So this is one type of problem. We're going to do another one. Okay. 4 over x minus 1 minus 4 over x squared minus x equals 2. Again, to help find the common denominator, it's going to be helpful to factor if we can. X minus 1 does not factor, but if we look, x squared and x both have a common factor, so that's nice. We can factor this into x times x minus 1. Then that makes your finding your common denominator considerably easier, because this one has an x minus 1. This one has an x minus 1, so we need that. We also have an x. We need that. And that's it. So whenever we multiply, my x minus 1's cancel, leaving me with 4x. Multiply here, the x and the x minus 1 cancel, leaving me with just a negative 4. And when I multiply here, nothing cancels, so we get 2 times x minus 1. All right, so in attempting to solve, we got to distribute. So 2 times x is 2x. Distribute that, we get 2x squared minus 2x. Now, remember, we covered this as well. Anytime you have an x squared, you have what's called a quadratic equation. So to solve this, we got to set it equal to 0. So we're going to move everything over. So I'm going to subtract 4x from both sides. I'm going to add my 4 to both sides. And I get 2x squared minus 6x plus 4. Now, remember, to solve a quadratic, we got to factor it. Okay, we get 2x plus 2 and x minus 8. We set each of our factors equal to 0. And not x minus 8, sorry, that should be a 2. 2 times 2 is 4, okay. Yeah. Okay, all right, so set my factors equal to 0. X could equal 2, that should be a negative. Okay, solve for x, 2x equals 2, and x could equal 1. So because we had a quadratic, we have 2 potential solutions. However, like I said, if you go back and double check, what's wrong with having this solution of 1? If I plug 1 in for x, what is 1 minus 1? Okay, that's 0. We cannot divide by 0. Dividing by 0 is bad. That causes this to give you an undefined solution. So while doing the math, we did everything correct. 1 should work, but in my domain, 1 has to be eliminated because it causes division by 0. So this is not a good solution. 2, however, is a valid solution. Okay, 2 minus 1 doesn't cause division by 0. 2 minus 1 times 2 doesn't cause division by 0. So this is a valid solution. This is the only solution that is going to work. So when it's all said and done, you need to double check. Does my solution cause division by 0? So because this one causes division by 0, this is no longer a valid solution. 1 is no good. Okay, I'm going to do one more example, and then I kind of want to talk about the test. All right. Okay, x plus 6 over x plus 5 equals 1 over x plus 5. It's really nice when they give you a common denominator like this, because then to get rid of it, that common denominator is pretty obvious. We're going to multiply everything by x plus 5. We'll multiply here. The x plus 5s cancel, giving you with x plus 6. And multiply here. The x plus 5 cancels, leaving me with 1. Easy enough. We go to solve, subtract 6 from both sides. X equals -5. That's my solution. Okay, especially if they give you a problem this easy, you kind of need to be like, hey, wait a minute, something doesn't quite add up. But if you look, okay, what do we notice about our solution though? What would happen if I plug -5 in for x, right? -5 plus 5 is 0. -5, again, needs to be eliminated. This causes division by 0. So we have to eliminate it. If we have to eliminate -5 and we don't have any other options, okay, then we say this has no solution, or that solution set is undefined. In my math lab, they have a bubble they want you to click that where you say that this is a no solution problem. So if your only answer causes division by 0, then you have no solutions. There is no number that I can plug in for x that would make this equation work. This equation has no solution. Okay, and that basically finishes up 6.5. They're going to give you a handful of different problems, but they all kind of fall in line with some of the examples that I went over. If you have more questions, you can definitely email me or let me know. You do again want to practice some of these problems. You want to make sure you're doing your homework. Points are good. In a math class, all points are good points. Make sure you get them. All right, as far as the test goes, okay, we are going to test over chapter 6. It was only 4 sections, starting with 6.1. Okay, 6.1 was all about simplifying expressions. Okay, again, talking about the domain, what numbers need to be eliminated, multiplication, and division. Okay, simplifying kind of gets brought out in all of these problems, especially in the complex fractions ones. So there will probably be just 1 or 2 where I'm just going to say, hey, simplify this, where it's not a complex fraction. Similarly, because the domain gets brought out in the solving of equations, there will just be 1 problem where tell you what, there will be 2 problems where I ask you what the domain of the function is. There will be 2 multiplication problems. There will be 2 division problems. Okay, 6.2 was addition and subtraction. Okay, there will be 4 addition and subtraction problems. I would anticipate 1 where you already have a common denominator, but most of them you're going to have to get the common denominator. Okay. 6.3, that's what we covered first. That's those complex fractions. That's the mother fractions. Okay, there will be 3 of those. I showed you level of difficulty, easy, medium, and hard. And then 6.5, the solving equations. Okay, there will be 3 of those. So this test doesn't cover that many different topics. So there was only 4 sections. You're looking at like 18-ish problems. Okay, so again, it's not going to take a ton of time, but that means each question is super duper important. If there's something you don't understand, you need to talk to me. Okay, or you need to find a way to figure it out, because if you have something where you leave something blank or don't do it, you're just shooting yourself in the foot. Okay, remember, points are good, just like I talked about on the homework. Same thing with tests. So make sure you can do these things. If you don't remember, again, you can go back and look at the videos. I save those, I put them in the Canvas course. If you look in Canvas, it says Zoom lesson over, okay, 6.1 and 6.2 or whatever. So go back, revisit that stuff, make sure you're prepared, okay? So we will test next week. However, we will still have class on Thursday. We've got too much information to cover to have, I don't want to say an off one, but I can't offer the test during class time. So next Thursday, I'm going to start chapter 7. Now, you can still test over chapter 6 after that. It's just going to be a lot of information in your brain. So I would recommend, taking the time you need to be prepared, but I would try to get my test taken before next Thursday, if at all possible. Okay, Monday, Tuesday, Wednesday, Thursday morning, okay, Thursday afternoon, whatever you can work out with your schedule. Okay, I understand life happens. But we need to have class Thursday. So on Thursday, I'm going to start chapter 7. Okay, so you need to find the time to take the test. If you can't get in and take the test till Friday or even early the following week, that's fine. It's just, anyway, the test goes live. You need to take the test probably next week. If it pushes into the following week, it's just going to be a lot on you. So questions? So weird just seeing my notes on the board and then talking to a screen. I don't know if you guys are getting all this. I hope so. But if you have questions, I assumed you would ask them. Again, you can email me. You've got my number to text. So if you need any help, I'm here to help. If not, that's all I got for this lesson. And I'll see everybody next Thursday. And remember, you got a test next week. Appreciate it. All right. See you guys. Okay. So,